Hello. Hello. Varun sir?
Yes, Vivek, it's audible.
Audible. Okay, okay. Okay.
Good morning, sir. Sir, am I audible?
Yes, they are audible.
Vivek. Hello.
Good morning, sir.
Good morning, sir. Good
morning. Morning, sir.
Good morning, sir.
Good morning,
People are
sir.
slowly joining, sir.
Hi, sir. Good morning.
Good morning, sir.
भैया आया क्या?
Sir, please put- I'll message him, sir. Hello, sir. Good morning, sir.
Yes, sir. Good morning, sir.
We'll start in a couple of minutes, sir.
Sure. I'm there.
Participants are joining.
Yeah, sure.
Already 100 participants are joined. I think we can start.
Okay, Shubhi, can start. It's 10 o'clock.
Good morning, everyone. A very warm welcome to the inaugural ceremony of the 5-day online certification course on Food Analysis and Quality Control, FAQC 2025. I, Shubhi, welcome you all on behalf of the Department of Food Process Engineering, NIT Rourkela. The quest for consumer safety and adherence to global standards makes the field of food analysis and quality control absolutely critical. Over the next 5 days, we will explore the essential science from regulatory compliance to the advanced analytical techniques. It is a great honor to see such an enthusiastic gathering of participants, and we are privileged to have with us today a distinguished array of guests. I now have the distinct privilege of welcoming our esteemed dignitaries to the virtual dais. We are honored by the presence of Professor Manish Okade sir, Associate Dean, Faculty Welfare, and our chief guest for the day, Professor Sabyasachi Mishra sir, Head of the Department of Food Process Engineering, NIT Rourkela, our dedicated course coordinator, Dr. Vivek Kambhampati sir, Assistant Professor, Department of Food Process Engineering, and our co-coordinator, Dr. Arun Prasad Venugopal sir, Assistant Professor, Department of Food Process Engineering. We thank you all for gracing this occasion. Now, let us commence the ceremony by invoking the light of knowledge. We request our dignitaries, Professor Manish Okade sir and Professor Sabyasachi Mishra sir, to light the virtual lamp symbolizing the removal of darkness and the dawn of wisdom. Thank you, sir. To begin our journey on an auspicious note, we seek the blessings of Lord Ganesha, the remover of obstacles. We now invite you to enjoy a brief presentation of the Ganesh Vandana video.
गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय भालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय भालचन्द्राय श्रीगणेशाय धीमहि.
Thank you, sir. To formally commence our program and provide an introduction to the vision behind this course, I invite the coordinator, Dr. Vivek Ambati, sir, Assistant Professor, to deliver the welcome address.
Thank you, Shubhi. Good morning, everyone. It gives me immense pleasure to welcome you all to this 5 days online certificate course on food analysis and quality control 2025. This course has been carefully designed to provide participants with a strong foundation in the principles and practices of food analysis and quality evaluation. Over the next 5 years, you will gain both theoretical and practical exposure from understanding the importance of food analysis and sampling techniques to advanced chromatographic and spectroscopic methods. And you will know about adulterants, how to detect it, and contaminants, microbial analysis, sensory evaluation, and quality control and quality management systems. We have also included sessions on rapid and non-destructive analytical methods, about food labeling and importance of reading the label and compliance with FSSAI and Codex regulations, as well as recent advancements in the food processing and future trends in the field. This comprehensive structure is intended to benefit students, research scholars, and professionals who are working in industry. Whether you plan to pursue a career in the food industry or academia, the learning from this particular course will certainly enhance your analytical skills and professional competence. At the outset, I would like to extend a very warm welcome and my heartfelt gratitude to our chief guest, Professor Manesh Wakade, Associate Dean, Faculty Welfare, and Associate Professor of Electrical Engineering Department, for joining us today. Sir has always been a strong motivator and constant supporter for such meaningful academic programs. His encouragement and guidance continuously inspire us to engage in such kind of activities. Thank you, sir, for joining us today. I would also like to express my sincere thanks to our head of the department, Professor Sabyasachi Mishra, sir, for his constant support and encouragement in organizing workshops and certificate programs like this. Especially he's always motivating our young faculty to take up such kind of initiatives, innovative initiatives, and has been a pillar of strength for our department activities. A special note of appreciation to my co-coordinator, Dr. Arun Prasad Venugopal, for being my constant support and backbone in organizing workshops and certificate courses here at NIT Rourkela. His dedication, coordination, and enthusiasm are truly unmatched, and I am deeply grateful for his unwavering support. I would also like to acknowledge the tremendous efforts of our PhD scholars who have shown great enthusiasm in preparing for this program, especially in developing the practical demonstration and tutorials. Their commitment and interest in both learning and delivering have been the driving force behind the practical components of this particular course. And I am sure you will witness their dedication throughout the sessions. My heartfelt thanks also goes to all the technical and supporting staff across the different departments who have worked tirelessly behind the scenes to make this event possible. The preparation of demonstration videos and smooth technical execution would not have been possible without their valuable assistance. We put in our 100% effort to make this course informative, interactive, and impactful. If any small glitches occur during the session, please let us know. We will address them immediately. I am also delighted to inform you that this particular program has received an overwhelming response with over 200 participants joining from outside and 40 are joining from our own institute. We are truly proud and honored to host you all. A very warm welcome to each and every one of you. Once again, I warmly welcome all the participants to this 5-day certificate course. I am confident that this program will definitely enrich your knowledge and strengthen your analytical understanding of food systems. Whether you move into industry or continue in research, the skills and insights gained here will undoubtedly serve you well in your professional journey. Thank you, and I wish all a very fruitful and enriching learning experience ahead. Thank you.
Thank you, sir, for your address. It's now my immense pleasure to invite our chief guest for the day, Professor Manish Okade, sir, Associate Dean, Faculty Welfare, NIT-Rourkela, to deliver the special address. Professor Okade is an accomplished faculty member whose research spans AI, video and image analysis, and information forensics and security. A true feather in his cap is having been the anchor of the 18th annual convocation with the Honorable President of India, Sri Ramnath Kovind ji, as the chief guest. He is also the recipient of the Early Career Research Award from SERB and has represented India on delegations to Japan and the UK. Sir, we are privileged to have you and your presence and guidance. Sir, please.
Yeah. Thank you very much for the brief introduction. And the dignitaries online, my fellow colleague, Professor Mishra, the course coordinators, Professor Vivek and Professor Arun, the enthusiastic participants. I could see that the number also yesterday, which it came around 200 plus participants. It's very good considering it's an online course. So to the very good morning to the participants too. So basically, I am here to just give a brief overview of my institute in my capacity as Associate Dean Faculty Welfare. More things about the department will be shared by my colleague, Professor Mishra, because his department is one among the very active departments. Whenever I cross the main gates, I always see banners saying that there is this course, there is Gyan course. Every time I see something or the other. So they are among the young department which was established roughly in 2013-14, but they have been catching up very well and they are one among the top departments of our institute. Coming to our institute, as we know now, we have Professor Uma Maheshwar Rao as our director, who is very enthusiastic, dynamic, and under his able guidance, NIT Rourkela has now upped the NIRF ladder. So we are now in the engineering category because food processing is an engineering. So in the engineering category, we are ranked 13th as per the latest NIRF ranking. The overall ranking also, we have done well with 34. In fact, food engineering is one of the branches which deals with sustainability. Sustainability also we have been doing very well, and we are the only NIT which is under 10, top 10 in sustainable ranking development goals of our the nation. Additionally, the architecture department is also doing well, and we are also ranked within top 10. So this is the broad overview of our institute in terms of national rankings. Internationally, we are doing very well in QS rankings, always ranked between 600 to 900, right from not only now, this year, consistently across the past 8 to 10 years, we have been ranked. Of course, sometimes ahead, sometimes a little bit, but we are featuring amongst the QS world ranking also, which is a which is a feather in the cap for the institute. Coming to the institute, we are having 20 departments. I just told that food processing is one of the engineering departments, and there are 15 plus faculty, and two of them are now the coordinators and doing very well. This is the broad overview. To the participants, I would just like to say that although it's an online course, food processing engineering also conducts several internship programs, short-term programs where they want the students to come in the campus. I have seen many ANRF programs where they take interns. When I was head of computer center, I used to do a lot of these checkpoint logins for food processing engineering. So I know that there are a lot of, so I would suggest these participants 200 plus. So whenever there is a next food processing engineering program, do watch our website and do come here physically, because if you come physically, you will get to know more. Those online, it may help some people who are working professionals, but do take some time out of your schedules and make it to our campus. As you can know, you would have seen on the website, our campus is lush green, around 650 acres of our campus, and we are all staying inside. You will really love this environment, which is supporting academic and research. With these few words, I would not like to take much time. With these few words, I would congratulate both the coordinators, the head of department, Professor Sabyasachi Mishra, as well as he said, there are so many people who would have contributed towards organizing this particular short-term program. So there are many such things. If I have not taken your names, you have to forgive me for that. So with these few words, I welcome all the participants and wish that across these 5 days, as I can see the name of the course is quality control. It's a very important part. So I wish that you learn a lot of quality control measures so that you contribute in sustainability to our nation. So with these few words, I hand it over to the coordinator. Thank you very much.
Thank you, sir.
Thank you so much, sir, for your noble words. Now, we move on to hear from the leader of our organizing department, Professor Sabyasachi Mishra, sir, head of the Department of Food Process Engineering, to deliver the keynote address. His areas of research is having a broad spectrum such as food packaging and storage engineering, food properties, post-harvest operations, food quality and safety, food process engineering, food science and technology, food safety and quality control, food packaging and storage, pre and post biotics. He is having teaching experience of more than 10 years. He is having 2 patents, more than 70 publications, and have guided more than 7 PhD students. I request Professor Sabyasachi Mishra, sir, head of the Department of Food Process Engineering, to deliver the keynote address. His perspective will surely illuminate the academic and industrial relevance of the food analysis and quality control. So please.
Good morning, all of you. Thank you, Subhi, Professor Manish, Arun, Vivek, and all participants and experts from the institute and from outside of the institute. It's a privilege for me, actually. It has been a dream for the institute to start the online or certificate program, not online, online and offline both. Our director has been very persuading on that, and probably we are on the right path. And with young minds like Vivek and Arun taking the lead, I am really quite impressed and happy and proud of my fellow colleagues. You have started a very good program. Our department started in 2013-14 with the BTech program, and we take students through JEE Main only. And being the topmost NIT, we get really very good students, and we are lucky about that, and we are proud of those students also. They are really doing wonderful things. At the same time, we started MTech program, and then obviously we start PhD program to boost up our research outcome, right? So in last uh, 10 to 12 years of our existence in the NIT system, our department has produced almost 948 SCI publications in 10 years. And the cherry on the cake is like this: in last 1 year only, this department has published 150 publications, and this is all credit goes to our students and our faculty colleagues. They are really doing good. And I take pride on that actually. As Manish sir was telling, our department has been leading in organizing many workshops, GAN courses, conferences, short-term courses, and now we are into this certificate programs also. This is the first time we are having it online, and probably I'll request the host and co-host, let's do it physically. Plan it like that. Department will support you in every aspect, and obviously our institute has been supporting for all such programs. Let's host all these people who are participating. Let them come here and have the feeling of NIT Raulkela. So we'll do that very in near future. Very certainly we'll do that. And this particular program, which is for 5 days, food analysis and quality control has been an issue from the beginning. In Indian system, there are rules and regulation, but implementation of those rules and regulation is a question. Even in our campus, NIT campus, we host almost 8,500 almost kind of students and many hostels. At times, I get calls from wardens and chief wardens, sir, can we send some sample for analysis of the raw material or the food? I tell them, okay, we can do that. We can always help you in finding out if there is some adulteration or something else. But the problem is that we cannot issue a certificate because we are not NABL accredited or FSSI accredited or certified agency. We are an academic institute. But imparting and transferring intelligence and knowledge to fellow colleague is our domain, our students. So I'm really happy that more than 200 students or participants have joined today's program for next 5 days. Anything and everything that is required for the successful organization of this program, I am always there as head of the department. And my fellow colleagues are always there. You will meet them in next 4 5 days, different courses. And I wish all of you all the best, and anything that you need, let me know. Okay. Wish you all the best, the coordinators, the host, and Professor Manish Okade. Thank you. You accepted our invitation and joined at the last moment. Thank you for joining and speaking so nicely about the department. I know he is a very good friend of mine, so always speak good about our department. But it's always good to have some perspective about yourself from somebody from outside, right? So thank you for joining, Professor Okade. Thank you, all of you. Wish you all the best.
Thank you.
Thank you so much, sir, for your valuable words. Finally, to conclude the formal inauguration ceremony, I invite our co-coordinator, Dr. Arun Prasad Venugopal, sir, Assistant Professor, Department of Food Process Engineering, to present the vote of thanks. So please.
Thank you, Subhi. Good morning, everyone. It's really a honor, and I'm really privileged to propose vote of thanks on behalf of Department of Food Process Engineering, National Institute of Technology, Rourkela, on this auspicious occasion. The inauguration of 5-day online certificate course on food analysis and quality control. So as our chief guest and HOD mentioned, it is this course is needed currently. Like, we come across adulteration, news about adulteration every day. So we need to increase the knowledge of food analysis and quality control with everyone. So with this note, I would like to express our heartfelt gratitude to our chief guest, Professor Manish Ukade, Associate Dean, Faculty Welfare, NIT Rourkela, for gracing this event with his presence and his inspiring address. Thank you, sir. Thank you for your kind words. And our sincerest thanks goes to our keynote speaker, Professor Samichachi Mishra, Professor in the Department of Food Process Engineering, for his insightful and thought-provoking remarks about the course. Sir, your guidance and continuous support are invaluable for the successful hosting of this program. As you mentioned, we are also planning for a certificate course on offline mode. So this online course is a basic certification course. It is basically for undergraduate students and the freshers who are working in an industrial sectors. So we are forced to conduct this in online mode. So definitely we will take your words, and with your guidance, definitely we will have host another certification course, advanced certification courses for the working professional in our campus itself. I would also like to thank the course coordinator, Dr. Vivek Kampampati, for his immense effort on conceptualizing, planning, and organizing this 5-day certificate course. And a warm thank you to all our distinguished speakers, participants, and the fellow colleagues from our department for their constant support. So your participation add great value to this learning initiative. Lastly, a special note of thanks to all the organizing committee members, our PhD students who are working in our lab are behind the scene, and their effort brings you a lot of successful event ahead. Once again, thank you all for your presence and goodwill. We look forward on intellectually stimulating and fruitful week ahead. Thank you, participants for joining.
Thank you so much, sir, for vote of thanks. With that, the inaugural ceremony of FAQC 2025 stands successfully concluded. Thank you all again for joining. Thank you so much.
Yeah, thank you very much. Thank you. Bye-bye.
Thank you, sir. Thank you, sir.
All the best.
I request participants to turn on your videos. We'll have a screenshot. The chief guest has left. Piyush, can you take the screenshot?
Yes, sir.
Please wait. I will invite HOD sir, and they left already.
No, I'm here only.
Okay, okay, sir.
Manish has left.
Uh-huh.
If it is possible to bring more participants in this frame.
Yes, sir, I will do.
Okay, I think it's fine. Okay, sir has left. Yes.
Yes, sir. We have taken these screenshots.
Okay, thank you, Piyush. Now we'll start the technical session. Should be kindly announced, please.
So thank you everyone for the technical session. I would like to invite my co-host Divya Darshini for the practical demonstration.
No, not. Okay, thank you, Shubhi. I think the first session is
Okay,
on the
before
importance of
that,
food analysis in the food industry. Okay, I will share the screen. Is the screen visible?
Yes, sir. Screen is visible.
Is it going to next slide, Piyush?
Yes, sir.
Okay, thank you very much. Good morning, all the participants. Thank you for joining online. I am Dr. Vivek Kamampati, Assistant Professor in the Department of Food Process Engineering, NIT Rourkela. So today I will be covering importance of food analysis in the food industry. So this particular course, it's of 20-hour course, right? So it will be starting from the theoretical aspects, and few practical aspects will be covering. Okay, this is an introduction session to introduce why food analysis is important in the food industry. Okay, these are the learning objectives of this particular course. First, I'll be defining the food analysis and its role in the food chain, and recognizing the analytical needs across R&D, quality control department, regulatory affairs, and trade. Right. So how this particular course will be useful at different food chains, I will be explaining you. And the next aspect is examine case studies showing impact of analytical testing and identifying the future trends and challenges. This is the flow of the presentation. I'll be covering different aspects here which are related to the basic food analysis aspects, right? So why food analysis matters? Why this is very much important? Okay, so definitely it ensures the safety of food and quality, authenticity and legality, right? So when I say authenticity, suppose for example, if you are purchasing a chicken meat, or maybe any kind of spices or any kind of food items, adulteration is possible, right? Authenticity, when you know that this food is authentic, okay, if there is no adulteration, then you say it as an authentic food. That's why it is very important to know okay, how to how to test for the authenticity. And legal matters, is also very much important when when you are planning for a trade. Okay, cross border trades or any kind of if you are sending your food to different states or different country, then you have to face the legal clearances. Okay, so these aspects are very important when it comes to food analysis. Then the next one is supports product development and shelf life studies. Definitely it will help us in developing a new product. If you are working in a lab, or if you are working in any kind of industry, definitely you will be doing a product development, right? So to test the product, you need to know about the analysis, what kind of method is important and what kind of method you need to use, and how to conduct the shelf life studies, right? Especially accelerated shelf life studies, that is very much important. Okay, the next aspect is protects consumers and brand reputation. Okay, so how it protects the consumer and brand reputation? Definitely, see, consumers, if they see any kind of good products available in the market, they stay connected and they keep on purchasing it again and again. Okay, when you say that particular brand is a successful brand, take an example of Nestle or Britannia, people purchase that brand again and again. Okay, the reputation matters, right? So that's how the brand will be developed. Okay, the next aspect is enables compliance with national and international regulations. Okay, when it comes to national regulations, we have FSSA in hand. Okay, Food Safety Authority of India, Standards Authority of India. When it comes to international regulations, we have Codex Alimentarius. We will be teaching you about the FSSA and Codex regulations in the little later sessions. Then food analysis across the value chain. Okay, what do you mean by a value chain? There are difference between the value. There is a difference between value chain and supply chain. What do you mean by a value chain? If you take a chain, okay, starting from the harvest, okay, starting from the harvest, especially in the food, I'm talking agriculture, commodity, starting from the field till it reaches the consumers, it undergoes different steps. Okay, it undergoes different processing steps, or maybe pre-processing and post-harvesting steps are involved. So each and every link in the chain is called as the supply chain. Each and every link has to create a value additionally, then it's called as the value chain. This food processing, a lot of values, you can add more value in each and every link of the chain, right? Starting from the raw material inspection till it reaches the consumer plate. Okay, raw material inspection is one value chain. The next one is in process monitoring. Okay, especially in the processing, and if you are doing any kind of operations like blending or mixing, or any kind of if you are using any equipment, oven, for bakery goods. Okay, in process monitoring is very much important. Why this is very much important? If you take an example of bread, so what should be the temperature required to bake the bread, how much time it has to be kept in the oven, okay, what are the processing conditions? So optimization is very much important. Why? It is indirectly connected with the customer satisfaction, right? Customers, they don't purchase darker breads, or they don't purchase harder breads. They require right kind of sensory attributes for the purchase. Then they keep on purchasing that particular brand again and again, that particular product again and again. Then that particular brand will become successful in the market, right? The next one is finished product release testing, then shelf life and storage monitoring. The last one is market surveillance and import export testing. So import export testing is very much important. Why import export testing is important? When you are sending your product abroad, okay, take an example. We are one of the leading producers of milk, right? We are number one in milk production. If you want to export paneer, or if you want to export cheese, there are a lot of stringent protocols you need to follow. Okay, when it comes to export, especially I'm talking inside our country, you have to follow FSSAI norms, FSSAI regulations and guidelines given by this particular safety organization. But when it comes to export, okay, you need to follow two things. One is internal quality, and then internal quality means inside our country, what are the quality aspects are required. When it goes to abroad, which country you are targeting, am I right? So that particular country has a food safety regulatory body, just like FSSAI, European Union regulatory body will be there. We need to adhere to those regulatory body guidelines, okay, especially when it comes to exports. Okay, so the core purpose of testing. So what is the core purpose of testing here? Number one is microbial toxic components. We need to identify, okay, whether the food is contaminated or whether the food is spoiled. Okay, indirectly you can how you can say, you can take out the sample, and then you can go with the microbial testing. You can say this much this particular food has this much plate count of total bacteria, or total fungi, or total plate count, maybe toxic compound. This is very much important. Okay, say for example aflatoxins, okay, or any kind of toxic components. Okay, it will be adulterated, or maybe naturally also it is possible that aflatoxin will be formed in the grains. Okay, take an example of peanut, okay, or maize per se. Okay, if you see, if there is any color change on the groundnut, greenish color, you can say that it is contaminated. It is the toxic components have been developed on the surface, aflatoxins, or maybe acrotoxin, mycotoxins. A lot of toxic compounds are there. So it is very important to analyze what toxic compounds are present in our food system. Okay, these two things are coming under the safety aspects. The next one is quality aspect. Okay, there is a difference between quality and safety. Am I right? Quality means what? It's a degree of excellence in achieving any kind of anything. Okay, say suppose for example, when I say quality, it's a quality biscuit. Okay, I am telling you example. Suppose if I say honey, which brand you trust? majority of you people will say, Dabur or any kind of, the well-reputed brands. Why? You say it's a, quality product. You say that if we trust that particular brand, this brand is existing, for more than, 100 years. And they have a very stringent protocols when it comes to quality. They don't compromise in the quality. Am I right? So that aspect is very much important. When it comes to safety, okay, how safe your food is for the consumption. Am I right? That's why this microbial and toxic compounds are coming in that particular aspect. Quality means nutritional as well as the sensory. If the food is not, it's not of a good quality, will not feel like consuming it, right? That's why the sensory attributes are very much important. What are the sensory attributes? Smell, taste, odor. Okay, all these things are sensory attributes. The next one is authenticity. Authenticity, in the last slide, I said this authenticity is very much important. Am I correct? Why the authenticity is important? Majority of the foods are being adulterated. Okay, recently, we heard about this news, adulteration of, adulteration in paneer, right? Adulteration in honey, and adulteration in meat. You name a product where, adulteration is not possible. Every kind of, food product is being adulterated. As a food technologist, directly or indirectly, we are linked with, this particular testing aspect. Some are working in industry, some are working in labs, some are research scholars, some are, undergrad students who will be working in the industry. We need to know about these adulterants. Okay, so section wise you can divide. Okay, there is a segment, right? If you take food, it has, liquid foods. In the liquid foods you have beverages, you have alcoholic beverages, non-alcoholic beverages. Under non-alcoholic beverages you have milk. Okay, you have, in the beverage you have honey, you have fruit juices. So according to your interest, you need to identify what kind of adulterants are possible. Okay, there are several thousands of adulterants are listed. Okay, we need to know what type of adulterants are being, mixed with, different foods. Especially, species ID. The species ID is very much important. Say suppose, for example, if I tell you the milk. Okay, A1 milk, A2 milk, there is, species identity, right? So cows which are, raised in our country, native cows are called as, A2 cows. You get A2 milk, you have A2 proteins in it. So these are authenticity. Okay, when it comes to, the vegetable products. Okay, somewhere, you get, oranges, very good quality oranges, is authentic Nagpur oranges. Okay, especially in the, northeast, there are, Meghalaya, Manipur oranges. Those oranges are also very much famous. Okay, these are, coming under this authenticity aspect. That's why the government of India, they are promoting one district, one product. Each and every district has its unique, agriculture commodity. That's why this government of India, they are promoting, different vegetables, different fruits. That's why they named it as one district, one product. The next one is compliance. In the compliance, regulatory bodies are there. They give, guidelines, label claims. They give a lot of, minimum residual levels. Okay, especially for, this in spices, a lot of fertilizer residues will be there. Okay, what is the maximum permissible quality that is required? Okay, so these regulatory compliances are very much important. They are, given by these regulatory bodies. The next aspect is types of analysis, commonly performed. What are the commonly performed analysis? So in the practical demonstration, you will be seeing all these things. Okay, proximate composition, microbial analysis, chemical contaminants, all these things you will be seeing in the practical sessions. This, here I will be giving you overview about this particular types of analysis, right? The first one is proximate analysis. You have, two different types of things under this proximate composition. The first one is micro, second one is macronutrients. Okay, under the macronutrients, this moisture, protein, fat, ash, mineral estimation are micro. And then if any phenols, phytochemicals are there, they are coming under micro. Carbohydrates are macronutrients. So all these micro and macronutrients will fall under this proximate composition. The next one is microbial analysis. In the microbial analysis, a total viable count is very much important. Okay, then what type of pathogens? Okay, suppose for example, if you take any food material, well, whether this is there is a chance of contamination for Clostridium botulinum, or is there any chance of contamination of salmonella? Okay, most of the foodborne illness, it will be caused due to salmonella. Okay, the bacteria, the salmonella type, when it enters into the body, you will fall sick. Okay, this you will get diarrhea, you will get this food indigestion. Okay, ingestion. Okay, so these things are very much important. That's why we need to know about the microbial analysis also. Okay, what type of bacteria, what type of fungi, especially in the fruits. Okay, you see mold. Okay, fungus and mold attacks will be there. Then we need to identify what type of fungus are most prone to this particular food system. We need to identify. Next one is chemical contaminants. In the chemical contaminants, we have heavy metals, right? Heavy metals, I will give you one example. In 2015, this Maggie case, I don't know you remember this or not. Many of us still eat Maggie, right? Am I correct? But in 2015, because of the heavy metal contamination, okay, this particular Maggie brand has to be stopped for around 6 months. Okay, so that's why this chemical contaminants is also very much important. Pesticide residues. Okay, so because of the one more thing, fertilizer residues is also very much important to analyze. Okay, then additives and residues. So what are additives and residues? Additives, in the additives you have preservatives also coming under the additives. Again, if you say classify the preservatives, we have class 1 preservatives and class 2 preservatives, right? Then next one is antibiotics. Can anybody tell where from where these antibiotics will be coming? Can any one of you can interact? Why this antibiotic test is very much important? Anyone? Participants?
From animal feed.
Very good. From animal. Can you tell any example? Which animal or
Broiler chicken.
Yes, very good. This is very good example. Broiler chickens. Every day, this broiler chicken is fed with antibiotics. Traces of antibiotics will be remaining in the broiler chicken body. That particular meat we are eating every day. I will tell you example. Our body, it will remove unnecessary residues, additives from from our body. It's okay, after ingestion, our body is very smart enough to recognize what are the intruders or what are the additives are not good for our health. It will remove. Okay, those who have suppressed immunity, they will be suffering. Okay, I'll tell you example. If we have children at our home, right? So when we give antibiotics, whenever they fall ill, okay, we'll not give it on a regular basis. Am I correct? We'll not give it in a regular basis, right? So whenever they fall ill, maybe if they have any food intoxication, or maybe if it is required, then only we'll give antibiotics, not every day. But broiler chickens, every day it is fed with a antibiotic. Majority of the broiler chickens are fed with antibiotics. Same way, other meat and meat related products also. This is very good example. The next one is milk. Okay, this animal related, I'm telling. Antibiotics will be given to cow. Okay, some traces. Okay, there is a chances, I'm telling. It's not 100% true that every time this antibiotic residues will fall in the milk, it will come in the milk, or maybe it will come in the meat. Okay, if a chicken or animal has very good health, their body will eliminate that particular antibiotics. Okay, if it is not, then it will come into the muscles, those meat will be eating. That is one thing. The next one is physical and sensory analysis, physico-chemical. First one is chemical proximate composition, the second last one is physical. Okay, in the physical aspects is very much important, right? So what type of analysis we will be doing under the physical aspects? Color, okay, texture, okay, and then the dimensions, how whether the commodity is big or small, or how it is. Okay, take an example of egg. We have 3 different grades of egg, right, based on the weight. Okay, similarly for different agriculture commodity, different grading systems are there. Accordingly, we need to analyze. These are coming under the physical properties. Sensory analysis, without sensory testing, the product will not be passed in the from the lab, right? It will not go into the market without the sensory analysis test by the sensory experts. A very good example I will tell you, wine sensory analysis is very much essential. Wine, beer, or any kind of food items, you name a food item, sensory analysis is very much important. Okay, then the next aspect is some routine analysis, and routine analysis versus the new trends. Okay, so why this routine analysis and new trends are required? So food sensitivities are growing. Okay, when you say food sensitive, what do you mean by food sensitivity? Can anybody tell food sensitivity? See, I want it as an interactive session rather just giving information from only one side. I think you people can answer, any one of you, whatever comes to your mind, you can discuss, right? Any idea about food sensitivity? Anyone? Any participants?
Health consciousness.
Yes. Any other thing? Food sensitivity.
Food allergies, like nut allergies.
Yes, very good, very good.
Adverse
Okay,
reaction to food.
very good, very good. Any other thing? Anyone else?
Lactose intolerance.
Yes, very nice, very nice. Lactose. Some people are allergic to lactose intolerance, lactose. Some people are allergic to, wheat. Some people are allergic to peanuts, right? Peanut allergy. Some people are allergic to eggs, egg protein. Protein allergies are growing. Lactose allergies are growing. Okay, you take, just get the information from the Google. Around 65 to 70% of the entire global population is lactose intolerant. Around 65% of Indian population is lactose intolerance. In coming years, this particular number will be increasing significantly. That's why people are, shifting towards plant-based. Okay, they don't want to consume milk. Slowly, this is happening. All of a sudden, if people are, converting into a, plant-based or vegan, they are completely leaving the dairy food, then there will be an imbalance, right? So the things are slowly migrating. That's why you hear a lot of times vegan food, vegan population is increasing. People don't want to consume any animal related foods. Even milk is also non-vegetarian. So slowly the shift is happening. Why? Because this is only because of the food sensitivity. Okay, especially it happens at any age. Even after immediately the people after 1 year, or maybe after immediate birth, people are allergic to so many different types of foods. That's why it is recommended till 1 year only mother's milk has to be given to the baby. Okay, to avoid all these allergies. Slowly the new foods will be introduced to the infant. Okay, one by one. Okay, so that is also very much important. Food allergies are growing. Okay, so how we will identify peanut proteins? We need to identify how this is linked with the food analysis. Is we need to analyze what type of protein is allergic to our body. Okay, so there are different types of proteins, right? So which protein, what is the structure? Okay, whether the protein is after ingestion it is further it is changing its structure or not. Okay, why this particular allergy is happening, the research is going on. That's why food sensitivities and food allergies both are very much important and both are different. What is the difference here? In food sensitivity you will have these kind of symptoms: bloating, joint pain, irritable bowel syndrome, headache. Okay, and then in the food allergies you can see that allergy either on the skin, on the digestion. Okay, not properly digesting. In the case of lactose you will get diarrhea, or maybe you will get some breathing issues after consuming your food. You'll get a breathing. Somebody is allergic to brinjal. Okay, they don't want to consume brinjal. Okay, so that's why we need to know the difference between food sensitivity and food allergies. Okay, regulatory drivers. Okay, what do you mean by regulatory drivers? Why testing is mandatory? Because food safety laws and standards. Okay, every food manufacturer has to get the FSSAI license. Am I correct? They need to follow the guidelines given by the regulatory bodies. Next one is for import and export, you need certifications. Am I correct? APEDA gives certification for export purpose. Okay, you need to get the certification from those agencies. Okay, FSSAI has accredited laboratories across our country. Some 18 accredited laboratories are there. Okay, if you have certification from them, okay, then there is a high chance of your product will be sold across the country. Okay, you can expand your circle. Then maximum residual limits are very much important when it comes to fertilizer residues, pesticides and all. Then enforcement, recalls. Why recall? What do you mean by recall here? Anybody? Anyone? What do you mean by recall? Recall in the food.
Calling out the product from the consumer,
Yes.
whole supply chain.
Very good. Okay, the manufacturer will send the product. Say, suppose for example, if you are into bread manufacturing, you produce 1 ton of the bread today, and that particular lot is out. And after 3 months, or maybe since this is bread, it has less shelf life. After 10 days, maybe most of the people, there is a trend in admitting into hospitals. They fall sick, or maybe they have some kind of issues. Then what will happen? That particular issue is because of what? Okay, then it will be identified from which product it has emerged, and then that particular lot has to be recalled. Just imagine if 1 ton of the material, it is going, okay, in the a lot of 1 ton, around half, 50% is sold, 50% is not sold. Okay, after 7 days, I'm telling. In the case of bread, you have only 7 days shelf life. Okay, within 7 days you identify that there is some problem. 50% lot is already sold, 50% lot is not sold. This 50% lot has to be recalled. So 500 kg of your lot has to be recalled. This is very small quantity. When you take Britannia or any kind of big brands, they manufacture a lot of quantity of the biscuits or breads or cakes, right? If something goes wrong, they have to recall. Just imagine how much cost is associated with that particular recall. Am I right? That's why it's better to go with the proper testing, to go with the proper quality control. Most of the industries, they think that having a quality control department is very much expensive. Okay, they don't have quality control department. So for them, if something goes wrong, then definitely they have to bear huge losses. Okay, that's why you need to go with proper testing protocol, proper testing procedures. You need to follow standard guidelines, you need to follow the regulatory aspects. Okay, all these things are very much important, right? The next aspect is business drivers. How this is linked with the economic rationale: prevents costly recalls and litigation. Okay, later on, if some consumer, they found hair in the product, they will file a case on that particular brand, and then they will get a hefty amount of money. Okay, These are some kind of litigations. Products, brand image, and consumer trust. Definitely, if your product quality is good, your brand image will stay good, and consumer trust will be there. Enables value added labeling. Okay, that is very much important nowadays. If you see, you go to any grocery stores, every the product label, if you read a label, nutritional claims will be there, whether allergen information will be given. Okay, so all these nutritional labeling is also very much important. Improves process efficiency and reduces waste. The cost of the quality is goes like this, right? So optimal quality level we need to maintain. Okay, so this is the graph between cost versus percentage defects. Okay, so the cost of the manufacturing, the total cost of the manufacturing, and this is the point where the optimal quality level will be there. Okay, prevention, inspection, internal failure, and external failure. These are some of the key points you will get from this cost of quality. Am I right? Then the role in product development and innovation. What are the role in product development and innovation? Validates reformulation. Okay, if suppose something goes wrong, after analysis you will know the sugar is less, or maybe salt is high, or this particular ingredient to this preservative I have added more, it has reached maximum permissible limit. All these things you can validate. Confirms functional ingredient performance, helps benchmark against the competitors. Okay, if you have proper analysis system in place, then definitely you can compete with the competitors. If you provide, I will give you one example. Cakes, right? Any brand, you take cakes. Normally, the Britannia cake, the moisture content is between 13% to 15%. Okay, or any kind of brand, not only Britannia, any cake if you take, it is 13 to 15. If you could able to increase 1% of the moisture, just imagine 1% of the total weight in 100 grams, 1 gram, or maybe in 100 kg, 1 kg you are increasing. That 1 kg water cost is less compared to the total solid cost, right? You can sell the 1 kg water for the same price. Okay, you need not to change the price. 13% moisture content cake cost around 30 rupees. 14% moisture content cost around same price, 30 rupees. Which one is beneficial? Definitely 14% moisture content is beneficial. Why? Because 1% moisture you are selling. Okay, instead of total solids. Total solid cost is more compared to the water, right? So in that you can correlate, and you can develop a product. Supports patent and claim. These things are also very much important. Then comes to quality control, quality assurance, and how these are linked with the food analysis. QC, what do you remember QC? QC is coming under the quality assurance, right? Quality assurance is broader picture. Quality control is a shorter picture, right? So it comes under the quality assurance. Quality control means what? Performs quality checks after production is complete. Whereas in the quality assurance, perform the quality checks before and during the production cycle. Before completing product, you are assuring that this particular product quality will be good after following this particular protocols. And in the quality control, if you see, scheduled based on production volume to ensure the continual quality, right? And goal is to satisfy the consumers. Definitely for both quality assurance and quality control, goal is to satisfy consumers. Okay, but these are the difference. In the quality assurance, you will you will be focusing on the system and process. Am I right? Rather than just focusing on the routine testing of the batches. Quality control officer, what he will do? He will do the testing of the product. Am I right? Quality assurance team, they will be dealing with HACCP. They will be dealing with ISO certification. They will be ensuring that particular system, the entire system will be correct. Okay. And what about the food analysis? Food analysis is coming under the part of QC and QA. Am I right? Technical tests that provide data for QC and QA for taking the decisions. These are the main difference between the QC, QA, and quality analysis. Some analytical methods are there. Okay. What are those analytical? We'll just have an overview, because in the practical demonstration, our PhD scholars, they will be explaining it little deeper. Okay. So we have two different types of methods. One is rapid screening method. The second one is confirmatory methods. In the rapid screening method, you have calorimetric kits, or maybe pH paper, rapid determination of the analytical methods. Okay, immediately you will get the result. Say suppose for example moisture I will give you. You have two different types of methods, right? One is using the moisture meter, the second one using the hot air oven method. Oven method normally it takes 1.5 hours to 2 hours. Okay, but in the case of rapid moisture determination using the machine, you will get the reading within 5 to 10 minutes, right? That is the difference between confirmatory and rapid screening method. Most of majority of the time the rapid methods are true. 90 to 95% it is true, but again validation is required. If you working in industry, if you are doing for rapid test for 10 sample, okay, 8 sample you do rapid test, 2 sample you go for the standard confirmatory test, or maybe regular AOAC method to cross check the results, right? So in the confirmatory test you have some sophisticated methods for high specificity and sensitivity. You'll get the accurate results. How do you get? Using some kind of instruments, GCMS, gas chromatography, liquid chromatography, or any kind of instrument which gives you high accurate results. Screening helps in confirmatory for enforcement or claims. Screening is very much important. Okay, I will give you some case studies. One is the first one, melamine in milk. I don't know how many of you know this melamine contamination. Melamine addition in the milk was trending in 2008. I think between 2003 to 2008, this was the hot topic. Okay, melamine. Why the melamine addition is common in milk, especially this particular thing has been identified in Chinese market. Okay, China milk industries, they used to add a lot of melamine to increase the protein content. Okay, this is the false increase in the protein content. Okay, melamine, it is rich in nitrogen. Earlier we had analysis test using the Geldal apparatus. Okay, in the Geldal apparatus, if you identify the protein, okay, if you want to determine how much protein is there, estimate the protein in the milk, you need to use the Geldal apparatus. Am I right? In the Geldal apparatus, you will get in terms of percentage nitrogen, then you have a formula to convert that into a protein. Am I right? So here melamine increases the protein. Nitrogen, because it has a lot of nitrogen, it increases the protein. Indirectly, it will give you the false report that this particular milk has a lot of protein. Okay, this kind of adulteration is possible. Okay, this is just an example I'm telling. What is the problem? Adulteration to falsely raise the apparent protein content in the milk. What is the impact? Who was the sufferers? Infants were the sufferers. This melamine was added in the infant, cow milk powder, infant formulation. Okay, just like Cerelac, we have a lot of infant formulas, right? Back then, a lot of infant formulas were there, which are made out of milk. There, melamine was added. A lot of infants were they were suffering from indigestion. They were not feeling well. How it was identified? It was identified because people, researchers, they observed a trend in particular age group after consuming this particular product. Then recalls happened. There is a huge loss to that particular company. I don't want to name any company here. Okay, loss of trust. It leads to loss of trust and legal actions. And then in 2008, FSSA also stringently, they made stringent protocols for melamine addition in food. In our country, they banned melamine later on. What are the lessons we learned here? Need for robust protein identification. We need to know what kind of protein is present in the different food items, how to measure it. Okay. Otherwise, we will not know. If you add melamine, we feel like percentage nitrogen is increasing in the Geldal result. So protein is high. We will correlate like that, right? So that's why we need to know which method is appropriate for finding the protein. This is an example I'm telling you. How do you identify? Some analytical conditions were given. Okay. Like HPLC, this is the instrument used back then to identify the melamine. Even now also you can use this. This is the machine, and these are the specification they have given. Column, they use this particular column, and then what is the flow rate of the mobile phase. If you follow these instructions, you can find how much quantity of melamine is present in your sample. Okay, here if you see, the detector used is UV visible spectroscopic detector. Okay, at 240 nanometer you can identify the melamine. There are different types of analytical methods are there to identify protein. Okay, so those one of those you will be learning in the second half practical demonstration. Okay, the protein content in food is often estimated indirectly by measuring the nitrogen content. As I said, intentionally adding non-protein substance to food will give you false results. This lead to the laboratory test showing a higher protein content than product actually has, right? So a lot of melamine wares are there in the market. Okay, partly this is safe. Okay, if you are going melamine tableware, some pros and cons I have given. Okay, you should not use that under high temperature. It's not suitable for microwave cooking, right? Then you should not clean it too much. You cannot scratch it too much because the melamine traces will leach into the food. Yes, it is durable, it is dishwashable, and it is lightweight. Because of these advantages, it is being used in different applications, but not in the food. Okay, this is the case study. You can see in this picture, a lot of infant food formulation are being dumped in the Chinese market. Then the World Health Organization reviewed the 2008 melamine contamination event of China. More than 51,900 infants and young children in China were hospitalized, especially for urinary problems. If you consume a lot of melamine, the renal failure will be there. Renal issues, urinary problems, possible renal tube blockages, kidney issues, kidney stones problem will be there. Okay. So these are the glimpses I have taken from the internet. The limits, what are the limits of using the melamine? The European Union, they set the limit at 2.5 mg per kg. US FDA, they set the limits 0.25 mg per kg. Okay. And they have stressed that infant formula sold to US consumer must be completely free of melamine. Okay. Even now in our country, FSSA, they have made stringent protocols. You can see here, FSSA has clarified that melamine substance is not allowed to add in any of the food product as an ingredient. Okay, this has been given by FSSA in the year 2008. This analytical lesson from the melamine case, what we learned? We learned just identifying the total nitrogen content will not give us the correct protein value. You need to go with the amino acid profiling. And then role of surveillance and rapid reporting systems, need for cross-sector coordination. So what do you mean by cross-sector coordination? Industries, they do it in a particular way. Labs, we do it in a particular way. Okay, if we are coordinating, if we are coming together, then definitely we'll have a fruitful results. Okay, what type of test we can conduct for determining this particular thing in order to avoid the contaminants, or maybe in order to avoid adulteration. These kind of positive things we can make when we have a cross sector coordination. So what you have to do to remove all these things, you need to, this is an example I've given, checklist you need to make. Okay, in the pre-fermentation, these are the fermentation stage when it comes to wine making. Pre-fermentation stage, fermentation stage, clarification, racking, aging, and bottling. Where you are adding sugar, pre-fermentation stage, tick. When you follow this kind of simple checklist in the industry, your job will be very easy. You need not to worry much about what I have done. Okay, what type of analysis methods you need to follow? You need to have a simple refractometer for estimating the sugar. For the pH, in every stage you will be determining the pH. You need pH meter. Titratable acidity, where you need to identify the titratable acidity. Okay, with what type of equipment is required? Ammonia, nitrogen, sulfur dioxide, turbidity. You need to list down what are all the things you are adding. So how you are identifying, in what different stages you are identifying. Am I making sense here? So this is very much important. Though this particular checklist looks very simple, but this is very helpful and handy. Okay, you have to maintain this particular especially when you are working in an industry. Then the next case study would be like this: olive oil adulteration. So what is the problem? Extra virgin coconut oil diluted with cheap oils. Okay, see, virgin oils are costly, right? Coconut, virgin coconut oil, virgin olive oil, or any kind of oils. If you take, these oils are costly. This, some industries, not the reputed ones, some small industries, what they do, they mix it, they adulterate with the cheap oils in percentage basis, so that you cannot identify. You will not get that smell. You will not get that texture difference, or maybe you will not find any kind of differences. Okay, so I will tell you one more good example. Adulteration of ghee. How people used to adulterate ghee? They mix pig fat. Pig fat is called as the lard. This lard was being adulterated in the pure ghee. Until and unless if you are not using any kind of other analytical methods to identify the purity of the ghee, you cannot say that this particular ghee is adulterated with the pig fat. Similarly for other food products also. That's why we need to know what type of technique is important, right? So here in the virgin coconut, other virgin oils, some sunflower oil, soybean oil are being adulterated in order to reduce the price. Okay. Some oil blends you can see here. How do you identify? You can identify using chemometrics, or you can identify using FTIR. You can identify using different techniques. Detection, fatty acid profile. If you do the fatty acid profile, you will know. Each and every fat has a fatty acid profile, right? Unique fatty acid profile. If you see coconut oil, it has a unique fatty acid profile. If you see olive oil, it has a unique fatty acid profile. Like that, different fatty acid profile. If you go with the fatty acid profile detection, then you can identify whether this is adulterated or not. What is the impact? Economic fraud, consumer depiction, trade disputes were there. See, this is a very good, way of determining the adulterated oil. This one I found from very good article published in 2024. Identification of oil adulteration using the thin layer chromatography. Right. See here in this picture, sunflower oil. Sunflower oil is used in all the A, B, C, D, E, all the images. It is adulterated with cotton oil, safflower oil, corn oil, sesame oil, and soy oil. Okay, this first in the image A, right? The first one is 100% sunflower oil. When you do the thin layer chromatographic profiling, you will get it like this. This is the result you will get. Okay. So the RF value will get between 0.043 to between 0.38 to 0.43, right? When you mix, when you see the 100% coconut oil, you will get it like this. The bands you can see, dark color band you are getting here, right? Just above. See here, if the sunflower is adulterated with coconut oil, cotton oil, 5%, 10%, 10, 25%, the band is slightly increasing. You can see this particular band is coming here in the last 25%. It tells that in this particular RF values, you can identify the adulteration of coconut oil using the thin layer chromatography. Same with the safflower. In the safflower, you can see the dark color band in the chromatography, the band is increasing, right? Don't worry about this particular image. I will be explaining this particular, how to identify or how to read the image in the chromatographic lecture. this particular image is coming here also. In this way, see here in the third image, corn oil, it has very small RF value 0.32. In 25%, if you increase what it says, if the percentage of adulteration is increasing, the adulterant oil band will be visible. It will be taking its place, right? Same here also. This particular band here in all the pictures you can see. This is how you can identify the adulteration using the thin layer chromatography. What is the interpretation from the summary? You can see adulterate oil, observation and interpretation, cottonseed oil. New bands appear near RF 0.3. These things I have already said. Indicates cottonseed specific compounds appear with the increasing adulteration. In the safflower oil, detectable adulteration at greater than 10%. Okay, these are the interpretation we can get from that picture. Analytical tools for authenticity. Authenticity, as I already told you, this is very much important, right? So how you can do the authenticity testing using the chromatography, GCMS, HPLC for liquid profiling, spectroscopy you can use for fingerprinting. Okay, fingerprinting of any kind of food materials, what type of unique components are present in the food items, DNA barcoding for species identification, chemometrics for pattern recognition. You can see here, this is the chemometrics. You can do it using the Raman spectroscopy. You can get the results like this. Different groups, functional groups, you can get the different chemometric patterns. Using that, you can identify what is the area and how much quantity of that particular group is present. Then the next case study is spice, pesticide residues in export consignment. As we all know that India is the leading exporter of spices. We are the leading growers of, we are leading in the production of spices, right? In the entire world. You name any spices, we are one of the leading producers, especially, the king of spices, pepper. 80% of world pepper is being produced in our country. Okay, what is the problem here? We send a lot of spice powders to the European Union. But what happens because of the pesticide residues and fertilizer residues, the entire lot will get rejected. This is the very common area. When I was, working with this Ministry of Commerce, especially, in this spice, spice segment, there we identified that around 100 pesticide residues were found in the branded spice powder. I don't want to name any spice powder. Okay, that's why we have a board, Spice Board of India. It's coming under the Ministry of Commerce. Okay, so they do all kind of certifications for checking the quality of the spices. What is the problem? Exceeding the minimal residual rivets, causing the shipment rejection. Consequences, definitely economic loss will be there, supply chain disruption will be there. Okay, so what we can do, we can improve our good manufacturing practices and good agricultural practices for the better keeping the quality of the spices before shipment. Okay, you can see here, this is the known case and it has come in the this is a recent case, right? Because of ethylene oxide. Okay, this normally this ethylene oxide is used in the medical industries for sterilizing some medical medical utensils. Okay, but this is being added in some of the spice powders. It is being rejected. Okay, and it does causes cancer. It's a carcinogenic element. We need to know how to identify the ethylene oxide. What are the rapid tests available? What are the normal AOAC protocol available? Lot of procedures are available, but we need to standardize the protocols here, right? Then comes microbial testing. Pathogens, most of the microbial contamination is due to 90% is due to Salmonella, E. coli, and Listeria. Okay, because of this, 98% outbreaks happen. Routine HACCP sampling risk reduces the incident especially in the industries, right? Environmental monitoring crucial in ready to eat related plants. You can see here acute diarrheal disease, it's increasing with respect to time from 2008 to 2017 data is available. Even food poisoning is also increasing because of poor hygienic practices, because most of the industries, they don't follow HACCP protocols. If the industries, though it is initially it is costly process, but in the long run definitely it will give good results to the industries. The next one is Listeria contamination case study in the ready to eat product. Okay, in the processing if you see this, how Listeria monocytogen enters into the food system. If you are eating any kind of animal related products, it will enter into the animal body, then it will enter into the food system in the industries, then it will enter into the consumer plate, and also indirectly it will contaminate the water sources, right? Because most of the soil, it has Listeria monocytogenes. We need to know how to identify the Listeria monocytogenes and what are the temperature requirements to kill the Listeria monocytogenes, right? Environmental testing is required, deep cleaning is required. That's why clean in place process is common in the food industries. Okay. Then nutrition analysis and label requirements. How many of us read labeling before purchasing a product? In one of the incident, I came to know that the lactating mother, she is very fond of drinking zero sugar Pepsi, right? This is 0 calorie Pepsi. She never used to see the labeling. Regularly she is consuming the zero Pepsi, or maybe zero added. I don't want to name any product, but just take it as an example. They clearly give it in their label that not recommended for children, pregnant or lactating women. But pregnant women and lactating women are also taking the Pepsi, thinking that it is safe, thinking that it will not add any kind of adverse, it will not create any adverse impact on their body. Okay, the companies, they clearly state everything on the label, but we do not read the label. Reading label is also very much important. Mandatory declarations will be there in the labeling. First one is macronutrients, selection of micronutrients also, it will be there like this. Analytical support required for low fat, high proteins, sources of fiber. For each and everything, you need analytical procedures, right? Periodic verification ensures the accurate labeling and consumer trust also. In the case study 5, if you see misleading organic or free range, now especially 1 or 2 years back, when I was working in Indian Institute of Plantation Management, every company they say, organic free, organic free, organic free. But later, during our survey, we identified that 95% of the foods organically sold on the name organic is sold or not organic. Starting from the field itself, it should be organic to claim it as organic free product, right? But we do not know what is organic, right? So that's why it is misleading the consumers also. As a food technologist, we should know what is organic. Starting from the field, everything should be organic. In the field, no fertilizers, no chemical fertilizers should be added, no pesticide residues, chemical contaminants, nothing should be added. Then during processing, no preservative should be added. Then during packaging, okay. So in the packaging also there is an issue. Ethylene oxide fumigations. I told you right in the last slide. Ethylene oxide part. This ethylene oxide, it will be sitting on the surface of the packaging material, and then it will be leaching into the food product. That is also important, right? What is the problem? Label claims not supported by supply chain evidences. What type of detection residue profiles will be there? Traceability audits has to be conducted. Certification checks has to be kept frequently, right? Which will definitely increases the consumer trust, and you can place your products in the premium category. Rapid methods and field testing. Practical examples. Handheld near infrared for moisture estimation or protein estimation. This is some of the rapid test, right? So you can use some sophisticated, instruments for rapid determination, both for protein or any kind of, luminescence test for hygienic checks. Right, you can have a swabbing and then go with the ATP bioluminescence. As your product will get illuminated if the microorganisms are there. You can have, toxicity screening also. The role of central and contract labs. So what is the role of central labs? FSSAI labs, or maybe CFTRI labs, accredited labs, NIFTM, accredited labs. Okay, what is the role of their, they have in-house QC labs handle routine checks and batch release. They test. If you send your sample, they are ready to give you the report, right? Contracted third-party labs offer advanced instrumentation and accreditation. You have labs, in the tier 1 cities, they give certifications. Accreditation is very much important to give the report for any kind of, food product, right? So make sure that you have this ISO IEC 17025 accreditation is there for that particular lab before sending your samples, right? That builds the credibility for the results. Then data integration and supply chain custody. So what is data integration? See, if you are giving your sample to the labs, they may misuse your data. That's why the data integration and custody should be there. Accurate record keeping should be there. Validated method should be there. Calibration should be there for the instrument or for the records for their, system, how they are following. Chain of custody, critical in legal or trade disputes. If something goes wrong, if you do not have a proper, record keeping mechanism, then definitely you will be in trouble. Okay, when it comes to any kind of legal or trade disputes. Then you can also go with the LIMS, okay, laboratory manual, information manual system, and electronic record keeping mechanism for traceability. So interpreting results also very much important. Uncertainty and decision limits. Okay, importance for method validation and proficiency testing, right? This is very much important. Then internal quality control. So how can we test the quality control in our labs? Use of blanks, right? So some of the labs, what they do, they give the standards. They do the standards once in a while. But it is recommended to do standard testing before each and every analysis of the sample in order to eliminate the errors. Okay, if suppose there is any human error, in the previous data, same thing will be carried forwarded. So better you do it again, even for the standards or blanks. Do that again and keep it ready whenever you get a sample from outside. Regular calibration of the instruments is important. You take an example of small weighing balance. If it is not regularly calibrated, then your results are wrong. Okay, why weighing balance is important? In the AOSA method or in any of the methods, it will be said that 5 grams of the sample is taken. If your weighing balance is wrong, you will take 6 grams or 4 grams instead of 5 grams. Am I right? So that will give you the wrong results. That's why calibration is important. Proficiency testing and interlab comparisons are also very much important. Then accreditation and regulatory regulations. You can see ISO accreditation for lab competence of lab testing, role in export certification. Okay, Spice Board of India is there, APEDA is there for certification. So many certification bodies are there for continuous improvement. They tell you, via third-party auditing or, via different mechanisms. You can have internal auditors for, continuous improvement. You can always go with the corrective actions. You can have Kaizen approach. You can have different approach for maintaining the quality. Okay, allergen declaration is also very much important nowadays. If a product has peanuts, nut allergy, or maybe peanut allergen information is required, right? Otherwise, brand recall will be there. Direct cost of recall, if you say in each and every segment value addition, value chain, it is a lot of costly process. Am I right? So investment in QC reduces long-term risk and expense. That's why QC, quality control, is very much important here. Consumer perception and brand value is also very much important. Give the good quality product, consumer will be satisfied. And you be transparent. You show your certification. whether it is organic or, whether it is halal or whether it is, what kind of certificate, what kind of process you have to be transparent. Then people will be connected to your brand. Am I right? And then this mycotoxin, toxin, micro, this is emerging threats, microplastic, new contaminants, those are, old contaminants. We know how to do that. But in the case of microplastic, we need to have a novel approach. Novel pesticides are there, and toxins and microorganisms, they are resistant to the fertilizer residues. Those things we need to explore. Climate is also very good example. Okay, which are not in our control, but we can, consider the climate also. Future trends. What are the future trends in food analysis? We have, sophisticated methods, integration system, rapid online sensors, right? Machine learning and chemometrics can be combined together. AI can be integrated. Okay, so many things are there. Digital transformation and automation in the laboratories also very much important, right? Capacity building is also very much important. Whatever happens in the market, it has to be migrated into the industries, right? By proper training and capacity building. Institute like us, we give a lot of capacity building training programs, okay, for industry experts or maybe the academia people. Okay, we can explore in this way. Harmonization and global trade implication. What are the changes are happening with respect to Codex Alimentarius? This also we need to learn, right? So these are very good examples. Maintaining the practical checklist in the industries. What to test and when to test is very much important. In process control is very much important. Finished process control is important, right? All these things we can easily manage if we have a practical checklist. And then risk-based approach. How much risk you can take. You can see here, as a consumer, he will think how much risk I can take. Okay, what type of product I can purchase, whether I have to go with premium segment product or medium risk product, medium segment product or low segment product. For industries also they think in this way, how much risk we can take. Okay, risk assessment is very much important nowadays. Okay, when we have a industry academia collaboration, then definitely we can improve all these things. Okay, so that's it from my first lecture, the importance of food analysis. What are the key takeaways here? We have learned about the basic importance, why we need to analyze the food products, and how it is linked with the health benefits, brand and trade, brand reputation, testing supports for R&D, quality control, combining the rapid screening and robust confirmatory methods like GCMS and all. We also looked into the aspect like why skill training is important, accreditation is important, what are the new trends in the digital tool. All these things are some of the key takeaways. I appreciate if somebody has any kind of questions, you can ask in this platform. Now the session is open for the discussion. Anybody has any kind of questions, you can please ask me. Participants.
Thank you so much, sir, for your informative session, lecture session.
Yes.
And I hope that all the students might have taken some insights, valuable insights. And now the lecture is open and for question answer session.
Yes.
So I would like to invite all, and I would like to request to please ask as much as
you can also drop mail in this mail ID. You can also contact us anytime if you have more question. If you have any quick questions, you can ask. Otherwise, the next session, I think already we are late. I think it's better we can start up, start with the next session. The speaker is ready. I will take up the questions in the WhatsApp group also, right? Okay, if any of the participants has any queries related to this particular lecture, they can contact in the WhatsApp lecture also. Shubhi, please
Yes,
introduce the next speaker.
Yeah. Okay, so our next speaker is Dr. Arun Prasad Venugopal sir. His areas of interest are post-harvest handling and storage of fresh commodities, extraction of bioactive compounds, and design and development of process equipment. He is having more than 10 plus years of teaching and research experience in food process engineering. He has done his PhD degree from agricultural process and food engineering from TNAU, and he is having more than 30 research publications, 10 popular technical articles, and he has also published one book. Now, we are going to start a new session of Dr. Anand Prasad Venugopal sir on the topic of sampling techniques and sample preparation in food analysis. So please start.
Thank you, Shubhi.
Thank you, sir.
Yes, am I audible now? Is the slides visible?
Sir, the slides are visible.
Yeah, good morning to all the participants. Myself, Dr. V. Arun Prasad, Assistant Professor from Department of Food Process Engineering, National Institute of Technology, Rourkela. So today we'll be discussing some important aspects about sampling techniques and the sample preparation in food analysis. If there is any difficulty in following me, please raise your hands. You would have heard about our institution, NIT Rourkela. It is one of the institute of national importance, ranking high in the engineering research and engineering education. In the recent NIRF ranking, NIT Rourkela stands in 13th position in engineering education in India. So we are on par with most of the top ranked institution in our country. So here we have food process engineering department where we offer BTech food process engineering, masters in food process engineering, and a PhD in food process engineering as well. Not only in India, globally, NIT is one of renowned institution. Times Higher Education, according to Times Education ranking, we are stands in the 600 to 800 band in engineering education, whereas in the QS Asia ranking, we are at the 78th position. So with this small introduction about our institution, we'll enter into this sampling and sample preparation for food analysis. Sample preparation is very important aspect when you're looking for a repetitive and reliable results in analysis. So most of the case when we are doing in laboratory experiments, we take a small lot of material, like we process only a small portion of a material. For a laboratory experiment, we rely on doing an experiment with a lower scale. So sampling will be a bigger issue in case of laboratory experiments and laboratory analysis of food samples. Whereas in case of industrial production and industrial sampling, there is a huge challenge arise when your handling capacity is higher. So uniform sampling or representative sampling of a whole bulk of processing is very difficult. So that is where these sampling techniques will give a hand. A sample is a limited quantity of something which is intended to be a similar and represent a large amount of things. So when you're going for a sampling, it should represent a large portion or the whole lot of samples which we are about to process or processed. Obtaining a portion that representing the whole
bulk of food material is very essential. The total quantity from which the sample is obtained is the population. So it should represent uniformly the population. It is important to clearly define what is your population. Like for example, in a per day or a per batch operation, if your handling capacity is 1 ton per batch, the samples should represent the whole population. Adequate sampling techniques helps ensure the same quality. So we need repetitive sampling for a larger quantity of handling. So the quantity of sampling and analytical data is a major determinant of database quality. When you are creating a database about the samples, about the quality of the samples, about the quality of the process, we should ensure adequate data is collected during the process. So for the objective of sampling, there are two objectives, only primary and secondary objective. The primary objective is to collect the food sample that are representative of a whole batch, then to ensure that the changes in the composition do not take place between collection and analysis. So after collection, between analysis, there should not be any changes take place in this within the samples. If there is the sample is intended to change, we have to provide such a condition for minimizing the change. Whereas the secondary objective of the sampling to document natural viability in sample as it relates to a factor such as season, geography, cultivar, and husbandry. So based on the growing condition, based on the production area, the sampling may vary. In such case, we have to make sure that we are representing the changes with respect to the geographical changes, cultivar changes, and the production process. Importance of sampling collections. The sample collection is very important to ensure that analytical data is reliable and draw a representative samples. So after the activities of analysis, collection of representative sample and the sample preparation, like if there is a sample preparation required, for example, for analysis of contaminants, for analysis of microbial changes, for estimation of heavy metals and nutritional components from the samples, it has to be grounded or it has to be thoroughly separated. Separation techniques, all these preparation techniques has to be in the sample preparation techniques, and analysis using proper methods and proper instrumentation. The potential source of variation for above activities, if there is any potential variation arise in the above activity, it has to be identified and minimized. So proper sample size, suitable container, or proper sampling equipments are required um, for proper sampling, as well as to avoid spoilage or changes during sampling. These are some of the terms. As you all know, as we discussed above, this sample is a portion of a selected larger quantity of population, whereas this sampling protocol, a predetermined procedure which allow us to collect samples, a representative sample of a whole population, and to minimize changes after collecting till analysis. And then the characteristics, the property of constituents that to be measured are noted, either the food nutrients or contaminants which need to be analyzed. Homogeneity of the samples, like the extent to which the property of a constitution is uniformly distributed. Foods are usually heterogeneous in nature, so we should ensure this food are thoroughly mixed before sampling. And sampling errors, even though we are following a sampling protocol, the possibilities of error in sampling is possible. A part of a total error associated with using only a fraction of the total population of the food is a major sampling problem. So when you have a heterogeneous food, if you are sampling a particular portion without proper ensuring the homogeneity of the samples, it leads to the wrong data. Because of the heterogeneous nature of the food, replicate sample must be taken when which ensures the composition is uniformly splitted. And batch, a quantity of food that is known or assumed to be produced under uniform condition. So for example, if you are processing your food in a batch, we are sure that throughout the batch it undergoes an uniform changes. So batch number should be always taken along with the samples, and then the unit, each of a discrete or identifiable unit of food that are suitable to remove from the population and label it as a sample. This unit from the basic forms a basis of most of the food analysis work. Example, an apple, a bunch of bananas, or a pack of biscuits, or a can of food, which is taken as a sample from a prepared food materials. The selection of representative sample and combined protocols for sampling and analysis must be based on a clear understanding of nature of the food materials and population of the food being studied, whether it is a heterogeneous food, whether it's a homogeneous food, whether it is a solid food material, a semi-solid food material, or a liquid food material, whether the sample is a raw sample or a processed food material, whether it is processed in a batch or whether it is processed in a continuous production unit. So all those things has to be taken into account when you are going for a sampling process. Precautions during sampling. So we need to provide certain precautions to avoid error in sampling. The condition of the sample received for examination is of primary importance. We should ensure the condition, like it should resemble the same condition when you are sampling, and it should resemble the same conditions when you are doing the analysis. Representative sample is essential when we are going for pathogen or toxicity analysis. The number of units that comprise of representative sample from the distinguished lot of product must be statistically significant. So we should ensure proper statistical sampling procedure according to whether the solid food is solid or semi-solid or viscous or liquid food materials must be determined by method of analysis at the time of sampling. Clean, dry, leak-proof, sterile containers need to be taken for sampling process. The sample must be submitted in the original condition and sealed condition without any contact with the atmospheric conditions. So we should avoid cross contamination, and we should avoid contact with atmospheric air, which induce oxidative changes in the samples. Dry canned foods that are not perishable can be collected and stored in a non-refrigerated conditions, whereas the sample which are subjected to biological changes and any oxidative changes or enzymatic changes need to be refrigerated, and we should ensure that the changes are very, very minimum within the time duration from sampling till analysis. There are some problems usually encountered by the analyst in preparation of the sample, which includes the representative samples maybe from a larger bulk of sample or bulk of commodity need to be ensured, and then the loss of plant material. So when you along during the sample procedures, usually they go for sampling by removing the unwanted undesirable portion from the materials. In some case where we are analyzing the nutritional quantity of the food materials, we remove the unnecessary material from the plant without affecting the food materials. Enzymatic changes before and during the analysis, and then the compositional changes with respect to reaction with the materials, like collecting tool or the storage containers. So after collection or during the collection, when you're storing the samples, it may interact with the environment, it may interact with the atmospheric gas composition, or it may undergo reactive changes with the container where it is stored. So usually we recommend a non-reactive containers, glass containers, or an inert plastic containers for storage of samples. Changes in them unsuitable, like unstable components and special preparations problems are analyzed in some case of oil seeds or fat materials. So the fat or enzymes which are present in the food materials are reactive. Maybe the fat get absorbed with if it comes in contact with the paper or any other absorbent materials. So this kind of changes or this kind of things has to be avoided during sample preparations. So source of food materials, like based on the source of food materials, the sampling technique may varies. Like if it is a bulk commodity, a bulk consignment of grain, a bulk containment of meat product or bulk of fruits, vegetables, wine, or edible fat. The compositional data obtained are commonly used in export surveillance of import parameters and changes during transportation, all those things. There are standard sampling procedures developed by organization, international organization for standards, or we have a EOAC method for sampling technique and codex procedures for sampling. Even FSSAI guidelines are available for sampling procedure for bulk commodity, and in case of wholesale commodities like bulk pack of food materials, bulk larger packs of food materials, which is used for processing, pre-processing as a raw materials. The sampling of wholesale food generally follows the principle of approach used with the bulk commodities. Excuse me, which is randomization of sampling is essential. And then the food compositional data also used in intake assessment. Retail food, the potential of regional variation also need to be covered in the design of sampling protocol. So when you're going for a retail food materials, like especially this proprietary food constitution an important range of food in many countries, and their compositional changes during the sampling and analysis has to be reduced. And then this where the database is prepared, there are already existing database for nutritional composition, as well as um, um, requirement of level of hazards, level of chemical hazards, or level of microbial hazards, microbial limits are already established by government agencies or food safety organizations. So we have to ensure the standard protocols within, and analysis of this potential hazards should be within the limits. Now so for existing for a bulk food materials which is imported, or for bulk raw materials, we may get a database, whereas in case of a field produce, or the produce which is or from a product which is obtained from a farm animal, or gathered from a cultivation area, these foods tends to have much variable with an existing database. We cannot rely on the existing database for any nutritional and compositional changes occurring within the samples. So the composition of the plant food is especially depends upon the soil fertility and fertilizers and input given during the growth or cultivation practices. So food compositions usually used mainly to access household or individual food and nutritional intake. Most field and garden produces is eaten seasonally as fresh and then preserved according to the traditional practices, where we don't much worry about the existing database in such case. Whereas uncultivated wild fruits, this is another category of foods which is coming into the market often during the season, or when it is collected from the wild source. So collecting a sample from these foods have a lot of associated problems. They may be difficult to identify or properly classify the category of composition, a category of food materials. It may change according to the collected area. It may be change according to the collected region and the maturity stage of the commodity. So it may be difficult to identify properly, and also the composition varies according to the maturity of the food materials. So where we go for random sampling, or this virtual sampling is impossible. So we have to go for convenient sampling as an opportunity arise as only, that is the only option where we have to go for convenient sampling. And then the food which is consumed, the food at the consumption level after cooking, or the sample taken from street food, which is prepared from a single or multiple ingredients. So these foods which are on the plate comprise cooked food of all kind, including complex mixture of dishes. So after cooking, during serving the plate, they may go for addition of some fresh ingredients which is beyond the cooking process. So in such case, there are potential hazards arise from the uncooked raw materials which is used for garnishing the dishes and all those things. So in such case, we cannot take the samples right away from the plates where it is not possible to collect samples from the street. We have to go for a simulation of cooking procedures in the laboratory conditions or in a dedicated kitchens which offer the sample preparation for analysis. So in such case, we should mimic the same processing method or same cooking method which is used in case of such dishes, and then we have to go for sampling in that. So major source of variability in nutritional composition, geographical sampling. So in a single country, there may be a wide variety of climatic conditions or wild variation in soil cultivation soil varieties and cultivation practices. So within India, we have different types of cultivation practices, and within India, we have a lot of climatic variation and soil diversity. So variation in food market and food preparation within a different part of the country has to be ensured. So geographically specific data may be available in database as a supplement to the nationwide or region-wide average. So we have a database, FSSAI database for particular food materials, which is for a specific region or of the country. We may rely on those data, and then we have seasonal samples. Seasonal variation in nutritional composition need to be accommodated in the combined protocol. The plant food are especially prone to variation, like water content, carbonation, and vitamin content varies widely with cultivation practices. And again, fishing. This fish, especially the fat content in the fish, milk samples, the composition of the milk and the vitamin constitution of the food are especially varied with respect to the season and with respect to the feeding pattern. So all this variation has to be addressed when we are going for a sampling. We cannot rely on the existing database, so we have to go for a sampling and analysis of the composition before using as an raw material. And then physiological state and maturity of the material. The state of the maturity of the plant and animal food causes variation in composition, like concentration of the sugar, concentration of organic acid, vitamin level in many plants, and the fat composition of the many animal food materials can be varied. So the storage of plant food affects the water and vitamin content and organic nutrients and residues of metabolic residues present in the food materials. So for example, you can say the cultivar and breed. Banana has a number of varieties. We produce number of varieties of banana. So this may be a significant source of variation of some nutrient composition. Like within the same varieties, we have a lot of subgenus. So it is desirable to document the cultivar or breed variation within the database. And for example, you have Cavendish, dark Cavendish variety bananas. We have this silk banana, which is Rastali, Puvan banana, Mysore banana, and then Nendran, Karpuravalli. There are so many different types of varieties of banana, and the composition changes varies according to the growth conditions and cultivation practices. So for sampling tool and sampling containers, so these are very important to have a repetitive data when you are going for sampling. The common tools such as filler, spoon, knife are used for making the sample or preparing the samples. And for liquid food materials, solid food materials, or food materials rich in oil, like oil, butter, we need containers which are non-reactive, like preferably glass container or plastic containers with wide mouth, wide closure, screw cap. All those things are necessary in case of collecting the sample and storing the sample. And the quantity of sample required for each analysis, like in case of if you are subjecting the food samples to nutritional quality analysis or hazards like chemical hazards or microbial load or chemical residues or pesticide residues, the level of the quantity of samples required may vary. For example, milk, we need raw milk, we need to have a 500 ml of samples from a bulk Whereas sterilized or pasteurized milk, we need 250 ml of samples. So these are some quantity of sample with respect to the analysis, intended analysis, and the process. Like for processed food materials like biscuits and cookies, we may need to take 200 grams of samples. Chocolates or pickles, we need 250 grams of samples. So this quantity varies. These are approximate quantity of sample need to be sent for a laboratory for analysis. If you are sending your samples for a different laboratory for analysis, this is the minimum quantity of samples required under each category. And then to send the sample, we need a sampling plan. So first we have to identify what is the type of food material, and then the size of the food articles to be sampled, like from a 1 ton bulk or from a 100 kg bulk. It depends upon the size of the raw material or processed food materials we are about to test, and then the degree of hazards to the human health. So whether it is having a pesticidal residue or whether it is having a microbial residues, so all those things has to be recorded. And then the potential fraud, adulteration fraud, and acceptance and rejection criteria, whether it is based on the adulteration or tolerance limits of the microbial composition or chemical residues, and the compositional changes and net content of the product. So sample preparations, in order to obtain the precise analytical research, the laboratory sample must be made as homogeneous as possible, so that within the limits we can replicate the same sample and we can get the same results. The purpose of a preparation is to mix thoroughly the large samples in a laboratory. This homogeneous sample must be uniformly sized for subsequent analysis. So if you come to method of sampling, we may adapt some sampling methods. It depends upon the type of food materials. So we have random sampling. The random sample are collected in such a way that it ensures the entire populations, and it is more useful in case of stratification of food population. And we have stratified a sample. In this method, the population is classified into smaller portions, and then accordingly the samples are taken. The small units of samples are taken from a bigger lot, and it is divided into sub divisions, and then the samples are taken. Often it is more suitable for for use in database work. So if you are going for a commodity from a particular region, or which is produced in the particular cultivation practice and particular season, we may go for the stratified samples to produce a database. Whereas selective samples, this selective sampling, the samples are taken according to the sampling plan that exclude the materials with certain characters, or selected materials only taken for analysis. Mostly this selective sample, we go for creating a nutritional database for a particular commodity. And then convenient sampling, mostly whatever sampling we are doing for agriculture commodities, which is coming under the category of convenient sampling only. The samples are taken on the basis of accessibility, cost, and other reasons which are not directly concerned with the sampling parameters. So this is not suitable for creating a database, maybe for knowing the quality of the product which is produced, knowing the parameters like chemical residues or pesticide residues or nutritional composition of a particular cultivar. This kind of convenient sampling can be used. So in all these methods of sampling, the compositional data obtained can only be estimated for composition of the food materials and are subjected to limitations. So for particular sampling of particular analysis, for example, we'll be seeing the sample preparation techniques for each and every analysis technique when you're discussing about. For example, when you're going for nutritional quality assessment, when you're going for structural analysis, when you're going for textural quality, when you're going for nutritional quality, the sample preparation technique may vary. So these are the general things which we have discussing as a sampling methods. Preparation of dry food for samplings. Mostly we go for grinding the food material and quadrating. So the dried food materials can be thoroughly um, grounded into coarse powder, and then we go for spreading it in a uniform surface and then making it a quadrating, and then we are separating 1/4 from the particular batch, and then again going for quadrating, repeating the quadrating process to get a smaller units from a larger bulk is possible. So grinding, usually we go for a coarse grinding. Even a small hammer mill or a burr mill will help us in size reducing the dry samples, especially grains, especially dried grains and pulses. We go for grinding the sample and then separate a small portion from a quadrating process. Whereas grinding in oil-rich substances like oil seeds or the groundnut or other some oil seeds, it may end up with oozing out of this oil from the cellular structures and release of enzymatic components. So mostly we go for completely dried food materials to avoid any changes after sample preparation. For example, and we have procedures for moist food. So most moist food such as meat product, the best homogenized by chopping rather than mincing. So for chocolate, cheese, it has to be grated into smaller portions before sampling. And then some moist materials are disintegrated best by bowl cutter, or some leafy vegetables or fleshy tubers or minced meat has to be grinded and then frozen, immediately frozen to avoid chemical changes until it sent to an analysis, until it is reaching the analysis process. The commercially available tissue grinders or small sample grinders are available for preparation of the samples. In such case, we can go for reducing the larger vegetables into a smaller portion, uniform portions, and then go for grinding before analysis. For preparation of semi-solid and liquid food materials, the fluid foods are best emulsified by top to bottom driven blender. So it has to be uniformly blended, and we have to ensure that homogeneous sample is taken from the semi-solid liquids and liquid samples. So pure, like for example, fruit juices, purees, ketchups has to be thoroughly blended before sampling, so that we ensure there is no sedimentation or fat layers or existing over the surface of this mixture. So gentle warming and mixing thoroughly, especially when you're going for oil samples. So oil samples, it tends to accumulate by adding some just gently warming the fat substances and go for thorough mixing, especially warming up to 35 degrees Celsius. So you should make sure that avoid further heat induced changes in the samples. Packing and sealing of the samples, like in order to maintain integrity and package containing the samples, we need to go for proper sealing in a containers, especially non-reactive containers, and avoid reactive containers, reactive materials come in contact with the food materials. So this kind of precautions has to be taken, and there are certain procedures which we have to follow during dispatch of the procedures. All the sample packed and dispatched must be from the shock absorbing materials, and the samples of frozen foods to be sent within overnight to the agency for analysis. And we have to pack it with dry ice to avoid further changes during transportation of the samples. And the documentations, the sample need to be addressed with certain documents for analysis. So where it is produced, what kind of sample it is, in which batch it is produced. So all those information has to be documented before along with the samples. So these are some of the forms which has to be attached along with the samples to before sending it to analysis. So commodity specific sampling procedures for adulteration, examination of adulteration, for examination of pathogenic microorganisms, for examination of harmful microorganisms. So there are separate sampling procedures, so which we will be discussing in our following lectures when we are discussing about the certain analytic techniques. We should be showing some sample preparation technique as well. So commodity specific sampling procedures are preparing your samples for certain analysis for high-end analytic techniques, like for your sample preparation technique for SIM analysis, sample preparation technique for your FTNIR, and sample preparation for texture analysis. All those things we'll be discussing in the following lectures when we are going for a specific test. We'll be showing your sample preparations also. So whatever we have discussed so far is a general procedures which has to be adopted for sampling. Thank you so much for listening and participating. If you have any query related to this things which we have discussed so far, you can ask me right away, or you can drop us a message in the chat box or in the group as well.
Thank you so much, sir, for your valuable and informative lecture session. Participants are requested to please ask questions, and if you have any query, please ask.
Yes, please. You can unmute yourself and ask questions, or if you're interested, you can drop a message in the chat box as well, so that I can read your question and answer. Okay, fine. Please be attentive in the following lectures. Our following lectures will be discussing about the sample analysis, sample preparation technique, along with the analysis technique and the data analysis also. Okay, thank you all.
Okay, so participants are requested to again join the session at 2 p.m. sharp. The next lecture will be done by Ms. Divya Darshini. The title will be Practical Demonstration of Proximate Analysis and Result Interpretation, Macro and Micronutrients. So participants kindly be on time. Thank you so much. Okay, you can leave the session. Thank you all for joining. Kindly join again at 2 p.m. Thank you.